Hello and welcome to Stat C1000 here at Kenyatta College. My name is Ray Lapuz, and in this video we will walk through an example from Chapter 8, Section 8.1, where we're looking for a confidence interval around a mean when we know the population standard deviation sigma. So we have an example, and I also have a link to the template spreadsheet that we're going to use. So just a note about this template spreadsheet: when you click and open it up, you will have to copy this. So you'll need to copy this, save as. So you go, I think, make a copy, and then make a copy to save it into your Google Drive. Okay, so once you have that, then you have access to it. It's yours, and you can use it, change it, or whatever. But you're not going to be able to edit this particular copy of it because this has to be shared with everybody. So we don't want it to be changing too much. Anyways, this is our calculating confidence interval for the mean when sigma is known calculator. And we have tabs for a bunch of other things for calculations we need to do in Chapter 8. Let's first get through some of these problems. It says, among various ethnic groups, the standard deviation of heights is known to be approximately 3 inches. We wish to construct the 95% confidence interval for the mean height of male Swedes. 48 male Swedes are surveyed, and the sample for this particular mean is 71 inches, and the sample standard deviation is 28. All right, just by looking through and reading through this stuff, and before we answer it, can see the things that we're going to need to answer anyways, but I want to write down on the side what we have. So among various ethnic groups, the standard deviation of heights is known to be approximately equal to 3. So this is not about the particular sample that we have, but rather this is about the whole population that we have. So sigma is going to be the 3. And that's going to be different from this sample standard deviation, which is going to be denoted by S. So before we jump to that, we wish to construct a 95% confidence. So your confidence level, also known as CL, is going to be 95%. We'll need to keep that in mind. And then 48 male Swedes are surveyed. So there's going to be an N value that's going to be 48. And then the sample mean, that is denoted by X bar, and that's 71. And the sample standard deviation denoted by S is going to be 2.8. Now, out of all these, we're not going to need the sample standard deviation 2.S because this is the section where we're going to assume that we know the population standard deviation, which is 3. All right, let's write down what they want. They want the X bar, and so that's 71. They want sigma, and that's equal to 3. And then they want N, which is equal to 48. So those are the 3 numbers that's going to be most important for us, along with the confidence level when we construct the CI, the confidence interval. In words, define the variable X and X bar. So let's do that down here. In words, for part B, X is going to be the random variable of the height of one person. So it's going to be height of one, we could be more specific, one male Swede. Okay, and then X bar, that's this one, is going to be the average. Let's call it mean, because now the word average is kind of diluted. We want to be specific and say the mean height of Now we have to identify that we actually have 48 male Swedes that we're talking about. And so the idea here is that we find 48 male Swedes, measure their heights, and then we find the average, and that's going to be one data point for this particular distribution X bar. Okay, so that is B, and let's go to C. Which distribution should we use for this problem? For C, since we know sigma, the population standard deviation, since we know sigma, we use the Z distribution. And remember the Z distribution, this is going to be the normal distribution with the mean of 0 and standard deviation of 1. So that is what we'll use for the distribution for this problem. Okay, now it says construct a 95% confidence for the population mean height of male Swedes. State the confidence interval, sketch the graph, calculate the error bound. Okay, so this is where we pull out our calculator. So we pull out our graphing or our calculator over here, and this is almost lined up to what they want. They want X bar, and so we will type in our X bar. So our X bar is 71. And then they want the sample size. The sample size N is 48. And here is the population standard deviation, which we should know, and that is 3 in this case. And then remember, the confidence level is the other confidence level that we need, which is 95%. So we want to write that as a decimal or type it up as a decimal. So that's 95. And then once you get all the inputs done, your outputs are ready to go. First of all, the critical Z value is given here, which they didn't ask for, but if we need to write it, it's round off to the nearest 3 decimal places. That's 1.9599, so I'll go 1.96. Let's write that down. Not needed, but let's write it down anyways. So for part D here, Z sub alpha over 2 is going to be 1.96. That's one of those standard numbers that you can try to memorize, but it's better to just have it available. Now the EBM is calculated by taking a look at Z sub alpha over 2 and then multiplying it by sigma divided by square root of n. So I see a 0.8486. I'm going to go 3 decimal places here as well. That's going to go 0.849. So our EBM is our error bound for the mean, 0.849. And so we will just add and subtract this from our X bar, our 71. So to find that, we're going to get 71 minus the EBM, 0.849, comma, and 71 plus 0.849. Now, the Google Sheets can definitely easily calculate that, and it's calculated down here. So we got 70.151 and 71.849. All right, so the confidence interval, call it CI, and we usually write the parentheses notation. We have 70.151 and 71.849. All right, so that is our confidence interval. That's one of the things that they wanted. They also wanted the graph and the error bound. So let me just highlight the error bound because it's already there. Now in terms of the graph, how's that graph going to look like? The graph is going to look something like this. We have a mean of 71, and our standard deviation is going to be sigma over square root of n. We don't need to worry about that. We want the error to be here, 70.151 and 71.849. And what we're saying here is that this area with the appropriate, so this is our mean, our x bar, let's call it x bar, a 71, and then your standard deviation is going to be the original standard deviation divided by the square root of n. So square root of n is square root of n was 48. So this is going to be a really small number and a small standard deviation, but we're saying that we're planning to catch, what is the CL? We're planning to catch 95% of our data within here. Okay, so this is our graph, our drawing, and that takes care of D. And then part C, what will happen to the level of confidence obtained if 1,000 male Swedes were surveyed instead of 48? So if we take a look at all the numbers that will change, so I'm sorry I didn't put down the formula, but let's put down the EBM formula. This is going to be Z sub alpha over 2 and then times sigma divided by square root of n. So if n gets larger, and here is to try to answer that question for part E. If we take a look at the EBM, and that's Z sub alpha over 2 divided or times sigma over root n. So we had n is equal to 48. And then we got this to be, let's see, 1.96 times 3 divided by square root of 48. So what happens if n gets larger? If n gets larger, this gets larger, then the whole fraction gets smaller. So fraction gets smaller. Fraction smaller. And now this is going to get smaller and this is going to get smaller. So the EBM will decrease. And so if the EBM decreases, remember EBM is this distance over here, EBM. If that gets smaller, then you'll have a smaller interval. So it'll be closer to 71. All right, we can double check that because we have our computer or calculator here handy for us. And all we have to do is change our n from 48 to 1,000. So I want you to keep your eye on the 71.1 and 70, or 70.1 and 71.8 once I change this 48 to 1,000. So 1,000, enter, and now it's 70.8 and 71.1. So it looks like that interval would have gotten us a lot smaller here. So 71.8 is a lot closer to 71, and 71.1 is closer. So sorry, that got a little bit messy, but that's what happens. We get a smaller interval. Okay, so another fun thing to do with this is that to change our different parameters to see what happens to the interval. Like if you change the confidence level, what happens to the interval? If you change the sample size, what happens to the interval? If you change the mean, what happens to the interval, etc. Just so you can play around with it. Now, before we go, I want to circle back and take a look at our confidence interval again. Our CI is going to be 70.151 and 71.849, but we always want to be able to say this in words, and so I'm going to come back and include this sentence that discusses what we just found. All right, we found a bunch of numbers. What do they actually mean? So we'll start off with the confidence level of 95. So we estimate with, and then we'll say a 95% confidence. So our first number here is 95% confidence. We estimate with 95% confidence that the true population mean, and then include this. So we want to change this according to the population mean. And we were measuring the heights of male Swedes. So population mean for the heights of male Swedes is between, and then now we get to put in the numbers that we were looking at. So what are those numbers? The first number is 71.151. So that's 71.151. And the other one is going to be 71.841 or 849. So 71.849. And then we are looking at this in inches, I believe. Inches, yes. So we'll include appropriate notation, and that's it. All right, so we want to make sure that we state in words what it is that we are saying with this confidence interval. All right, and I hope that helps.